So now we're going to graph the cosine of x. Okay? So here we're just going to talk about the major landmarks of the cosine of x. And so basically that's what we're going to do in this video, just like the previous video on the sine. Okay? So now here I want to recap here our unit circle. Okay? And I want you to remember that the cosine corresponds to the x coordinate on the terminal side of an angle in standard position. Okay, so for example, if I have here, like let's say the initial side of an angle on the positive x-axis, and I open it up theta degrees like this, or theta radians, whatever the case may be, then this intersection point of the terminal side of the angle with the unit circle, that x coordinate is going to be exactly the cosine of the theta here, and of course the y coordinate is the sine theta. Okay? Okay. So now let's think about this for a moment. So we now know that this angle, of course, is going to be 0 radians, right? This is going to be pi over 2 radians. This is, of course, pi radians. This is 3 pi over 2. And of course, here at 0, coterminal with that is, of course, 2 pi, right? And so just as before, we're going to look at our major landmarks for our cosine. Now watch this. Let me put x here and cosine of x here. Now let's look at this together. If I'm here at the angle 0 radians, then that's going to be the intersection of my terminal side of the angle with the unit circle. In fact, you can see that since the angle is open at 0 degrees, that means it's actually not open. The terminal side lines up exactly with the initial side, okay? And so, and of course, remember, unit circle means unit radius, right? So the point of intersection here will be nothing but 1, 0. And since the x-coordinate is the cosine, that means that the cosine value will be 1 for 0 radians. Okay? Okay. If you look at pi over 2 here, that's going to be the point of intersection of the terminal side with the unit circle, right? And you can see what is the coordinates of this point? 0, 1, right? Because it's 0 along the x, 1 along the y. The 0 is the x-coordinate, and so at pi over 2, we will get 0. Okay? At pi, you can see this is going to be the intersection point of the terminal side of the angle in standard position with measurement pi radians. And you can see that the x-coordinate here will be negative 1, 0. So that since the x-coordinate is negative 1, the cosine here will be negative 1. Okay, so that's pi. At 3 pi over 2, you can see that it'll be 0, right? Because if you look here at the 3 pi over 2, that terminal side intersects the unit circle at the point with coordinates 0, negative 1. And the x-coordinate is 0. The cosine is the x-coordinate of the intersection point of the terminal side with the unit circle, and so therefore the cosine here is 0. Finally, at 2 pi, which is coterminal with the angle of 0 radians, that must also be 1. And if you graph this on the xy axis with these points, right, then your shape will look like this. Okay, that's bad. Okay. Like this. Here, of course, 0, 1, right? Here, that's it. Let me draw this in as a dotted just so that I don't clutter our diagram. This is at pi over 2. You see it crosses 0 at pi over 2. It crosses 0 again at 3 pi over 2. By the way, those are just dotted lines, so I don't put the numbers here so that it keeps our diagram looking very beautiful. There, that's an angle pi. You can see how at pi it's at negative 1 over here, right? Here, of course, it's at 1, right? Okay. And there you have it. That's the way the cosine graph is going to look. And just some facts here. So except for these like lines, I just wanted to show you that these are the locations of the angles pi over 2 and 3 pi over 2. Okay, so it'll look like this, right? So, okay. Right, okay. Now it looks beautiful. Okay, the cosine of theta has period 2 pi. It has domain from negative infinity to infinity, and it has range from negative 1 to 1. Okay. Let me just, so why does it have period 2 pi? Because you can see that as you go from 0 all the way to 2 pi, you trace out this curve in terms of the distance x-wise from the central axis, right? That's in fact, for example, at angle 0, you can see that distance is 1. Well, of course, because it's the x coordinate, right? So that's that distance. That's why this is 1. If I go up here, let's say to 45 degrees, so I would be here, you can see that the x coordinate, the x distance, let's say, would be this much. That's why it's this much here. You see? Once I get here, you can see the distance from the x is 0. That's why I'm 0 high. And as I trace out this way, what's the x? Well, it'll be that. So that's why it's that here. Right? So as I turn around, as I go around the unit circle, right, I draw out this shape in terms of the distance that x takes from the 0. Positive this way goes up from the x-axis, and as I go negative, I go below the x-axis, right, until I get over here to pi. See, at pi, I'm as far as I'm going to get from the x-axis, exactly negative 1. That's why I dropped to negative 1. And once I go back to 0, or when I started from 0, I'm as far to the right as I'm going to be, because that's how far the cosine will go, namely positive 1. That's why the range goes from negative 1 to 1, because it cannot go beyond that. And of course, I can continue duplicating this period as I wrap around the unit circle. That's why the domain is from negative infinity to infinity, because this piece will repeat this way forever, and it will repeat this way forever. And the period is 2 pi, because to draw out this full shape, this full period, we need 2 pi radians. Okay? Now, in any case, these are the main landmarks you need to know to graph any cosine function you need. Thank you. You're still there? You're watching this video? Well, I hope you enjoyed it. In any case, if you did enjoy it, well, I encourage you to like it. Put that big thumbs up there. And don't hesitate and don't forget to subscribe to my channel. And anyway, and also add a comment if you want me to cover up some particular topic. I can't make any promises. There's a huge list of topics I already want to cover, but time permitting, I may address that topic. And in any case, I hope you've enjoyed this video, and thank you again.